Alright, so let's start. I believe we're at the bottom of page 2, and we're in a box. Yes. Okay, so in general, yesterday, you learned that we can write a vector in component form. So component form has the, what did we call them yesterday, duckbills?
Yes.
Okay, so component form has the duckbills, or we can write it as a linear combination of I and j, and that's xi plus yj. Okay? So in general, we learned yesterday that the x part in the component form is equal to the magnitude of v times the cosine of v's direction angle. We also learned that the y part then is the magnitude of v times the sine of v's direction angle. Magnitude, we said yesterday, was the length of the vector. It also represents the force behind that vector. And so we defined it using the Pythagorean theorem as the square root of x squared plus y squared. And our reference angle for theta, or for our direction angle, I should say, we said was the inverse tangent of y over x. But what did we do with those? We dropped all negative signs. Yep. If they're both negative, it doesn't matter. You don't have to drop them both. But if one of them is positive and one of them is negative, then you got to drop the negative. Okay. All right. So let's continue on down the pathway of other functions or things that we can do, operations that we can do with vectors. Okay? So if we suppose that vector v in component form is negative 2, 5, that would mean then that if I drew out, oops, tap the brakes, that one kind of went a little cattywampus. Now we're back to square, okay? So that would mean then that if I drew out that vector, it would be somewhere up here, correct? Alright. So that vector is going up and to the left, right? Okay. That's where all that force is going. Okay. What if I said negative v, though? Negative of that vector. What do you think would happen with everything associated with that vector? What do you think would happen? What do you mean it would be flipped diagonally? So you would switch all the directions, right? We would, it's going in the total opposite direction, right? So in terms of my reference angle, or I shouldn't even say my reference angle, my direction angle, right? How are the direction angles related? Because I could say something like, it could go down and to the right like that, right? But how would my reference angle, or not my, I keep wanting to say reference angle, my direction angles, Ben?
Would they add up to 180?
They wouldn't add up to be 180, but there would be a difference of
A difference of 180.
Okay? Yep, so there would be a difference of 180. So it goes in the complete and opposite direction. Okay? So as Ms. Senanaika was saying, instead of going left 2 and up 5, we would go right 2 and down 5. Okay? It's kind of like if you took a negative 1 and distributed it in to that vector. Like scalar multiplication of the vector. Okay?
I'm confused as to what you were talking about with the difference of 180.
So remember so the red is the original direction angle. Blue here now is the new direction angle. So blue minus red is got to be 180.
Okay.
Okay? If it's just the negative, you know what I mean?
Yep.
Because it's got to go in the complete opposite direction. Okay? You know what I mean?
Yep.
So if I'm walking towards the door,
Yep.
the complete opposite direction is back towards that board. Okay? It's not towards you right now.
Yep.
Okay? Right? Okay? Did I skip one? No, I didn't. So suppose u is equal to negative 2, 5, and v is equal to 3, negative 2. All right, well, let's put u on there. We'll put u in red. So negative 2, 2, 4, 5 goes way up there. And remember, you can't just draw a segment. You got to put an arrowhead on it because it's a vector. Okay, so there's u. Now we got to put v on there. We'll put v in green. 3, 1, 2, 3, negative 2 is down there. So there's v. Oops, I forgot to put v on there. Okay. So then u plus v. Okay? Well, there's a couple of different things going on here. If you think about it in terms of forces, we've got forces acting almost in different or I shouldn't say almost, in opposite directions. Or, you know, they're counteracting one another. Okay? So one way to do it, and it doesn't have to be always done this way, is to go to head to tail. Okay? So instead of putting v down there at the origin where it normally is, I could put v, let me put the other v, in at the head of u. So that would be right 3 and down 2. So this would also be v right there. And then my result would be that's a bad head, but try that one again. Okay? So there would be my result, which would be at there, and that is u plus v, which is at the point 1. Oops, I put point, not got the brakes. Duckbills. 1, 3.
What is the maroon line?
This purple one up here,
No, yeah.
the maroon, that's my u plus v.
Did you just connect them?
Because I went u, which is red,
Yep.
then I went v at the end of u, I put v in there, so that gives me u plus v because I went u and then I went v.
Can you just add the difference?
Tap the brakes, child. Okay? Don't bury the lead. Okay? That's one way of doing it. Okay? But you won't always have graph paper. Okay? Tasha, what's the other way of doing it? Add the x parts and add the y parts. Okay? So this could also be the vector -2 plus 3, comma, 5 plus -2, which would give me the vector u plus v of 1, comma, 3. Okay. There's also what's called the parallelogram method, okay, which is, so you put u on there, you put v on there, and then you make a parallelogram where the red side is, let me go dashed with this. So then the red side is there, and then you'd go up 5, 1, 2, 3, 4, 5, 1, 2. So you'd have this, and then that, and so then you make your parallelogram out of it, and it's the opposite vertex of the parallelogram. Okay? That's another way. There's many different ways to do it. Easiest way is you just add the component forms. Okay? That's the easiest way to add or subtract vectors. Okay? 3 times v, then, okay? So v now is here. So 3, -2, so there's v. Bad head again. Oh, Max, here, hold on. I don't want you to, be behind. Okay? So there's one of them, right? That's 1v, right? Well, then I could put in 2 v's, right? And then I would put in 3 v's. Right? Each time I'm going over 3, or to the right 3, I hate the word over. I don't know why I just used it there. Each time I'm going to the right 3, and down 2. So this ends up being at the point down here, 9, 6, which means that my vector then, my 3v vector, would be the vector in component form, 9, 6. Oh, sorry, yes, -6. Good catch. Okay. What's an easier way to do it? Multiply the x and the y part by 3.
If it was then find -3v, would you go on the graph in the opposite?
So you'd go in the opposite direction, right? 180 degree different direction angle, 3 v's.
Starting at the head of the,
Starting right
or at the origin.
at the origin, because that's where you started with v.
Okay, so you just get negative.
You'd have -9, +6.
Right.
Okay? So u is -2 2, 2, 4, 5. That's this one again. V is 3 comma negative 2, but I want to subtract them, right? So instead of putting V on the graph, what would I really want to put on the graph? Opposite of V, right? Right there is negative V. Okay. So again, I could go tail to head. So I could put the green tail at the red head. So my resultant, not very straight, close enough, vector is that one, which would be 1, 2, 3, 4, 5, 6, 7. Okay. What's the easier way? Subtract your x's and subtract your y's. So u minus v here is going to be negative 2 minus 3 and 5 minus negative 2, which is negative 5 and 7. Okay.
Do you have to draw the original vector, like the negative b, the green one, or no? Because it's your element to it.
Depends on which way you want to go with it. Yeah. Yeah. I mean, you could wait to draw it until like I drew where the purple one is.
Mm-hmm.
Yeah, you could wait to draw it right there. Yeah. Mm-hmm. But 9 times out of 10, you're just going to subtract the components anyways. You know what I mean? You won't even draw it. And we're fine with that. You know what I mean? Okay? So, go ahead. Yeah.
So do you switch them when you were drawing it on the graph?
I switched them because u minus v is really u plus opposite of v.
But you don't do that when you're solving it this easier way? You don't?
Just, it's the same thing. I mean, really this here is negative 2 plus negative 3. We just wrote it as negative 2 minus 3. You know what I mean?
Yep.
5 plus 2. Okay. So, on your sheet there, we've got U, V, R, and T. I would like you to answer me those 5 questions. Alrighty then. So, U plus V. U plus V would be negative 1 plus 2 and 3 plus negative 5, which would give me the vector 1 comma negative 2. Concur. Do we have an accord? Yes. Okay, that's a good thing. Then U minus V would be negative 1 minus 2 and 3 minus negative 5. So that would be negative 3 and 8. Do we have an accord? Sweet. T times U is going to be negative 3 times this vector, negative 1, 3. So that's going to be 3, comma, negative 9. Do we have an accord?
Yep.
Fantastic. RV, so that's going to be, oh, excuse me, yeah, that's RV, 2 times 2, negative 5, and then plus negative 3 times negative 1, 3. So that's going to be 4, comma, negative 10, and 3, comma, negative 9. So that's going to give my 7, comma, negative 19. Do we have an accord? Yes? Negative RU would be negative 2 times negative 1 and 3. So that's going to be, let me drop this down a little bit now. A little bit. That's going to give me 2, comma, negative 6. Yeah, buddy. Sweet. Okay. Okay. Oh, yeah. Yeah. Okay. So it says find u plus v in component form, then find the magnitude of it, and then find the direction angle of it. I think you can do this one. Try it. Try it, and you will see. So before we go, we got to find u and v in component form. So u is going to be 2 times the cosine of 30 degrees, and 2 times the sine of 30 degrees. V is going to be 3 times the cosine of 90 degrees, and 3 times the sine of 90 degrees. Okay? So before we even do that, we have to go there. So cosine of 30, if I use my unit circle, so cosine of 30 degrees is the square root of 3 over 2. So 2 times that is going to then be the square root of 3. The sine at 30 degrees is 1/2 times 2 then is going to be 1. Cosine at 90 degrees is 0. Sine at 90 degrees is 1. So I get those two for my u and my v. Yes? Okay. So then u plus v in component form is going to be the square root of 3 plus 0, which is the square root of 3, and 1 plus 3, which is 4. So that is the component form of my vector. Yes? Okay. Now, if you rounded the square root of 3 to whatever it is, 1.714, is it?
1.732.
1.732, it's like the other 1.714. If you rounded it, that's okay, but you got to keep it on your calculator then.
So why did you get it to just stay at the square root of 3? So when I solved for it, I just gave the 1.
I used the unit circle, I didn't use the calculator. You know what I mean? I went over here and I said the cosine is the square root of 3 over 2. Multiply that by 2 is just the square root of 3. Because it was a unit circle.
Yeah.
Okay? So my magnitude then is going to be equal to the square root of x squared plus y squared, which in this case then is going to be the square root of 3 squared plus 4 squared, and then taking the square root thereof. So that is 3 plus 16. So I get the magnitude here is the square root of 19. Concur? Yes? Okay. My question to you is this. I can scroll all the way down to here now. which quadrant is the vector u plus v in? It's in quadrant 1, okay? Which is good to know because my reference angle then is equal to my actual angle in quadrant 1. Okay? So I don't have to do any extra figuring there. So the direction angle of that u plus v vector is going to be the inverse tangent of y divided by x. When you type that into a calculator, you should get somewhere in the neighborhood of 66.5868 degrees. And I don't have to do any extra figuring because I am in quadrant 1. If I was in quadrant 2, I would have to subtract that reference angle from 180 degrees. If I was in quadrant 3, I'd have to add that reference angle to 180 degrees. If I was in quadrant 4, I'd have to subtract that reference angle from 360 degrees in order to find what the actual direction angle is.
How do you know your quadrant 1?
Because I have a positive vector. Remember
Or the first part of A or the end?
this part right here. U plus V is what I'm looking for.
Square root of 3 up 4 positive.
Okay? Just like points, Eden, just like points, the vector, the x and the y components in the component form will tell you which quadrant you're in. Just exactly like points. Because they represent the point that my vector ends at. Okay? Alright? So you're going to need one of these goldenrod sheets today. I'll put them out over here. Okay? So as you're leaving, come grab one right off the cart. Okay? Have a great day.